Welcome to Database Compression Best Practices. What you need to know. My name is Greg Chrisman. I'm the product manager for advanced compression. Let's get started, shall we? A common question we hear quite a bit is what applications can use compression? Well, it's about everything you can think of. Any commercial and or packaged application, including eBusiness Suite, PeopleSoft, JD Edwards, Siebel, and more, and that does not require changes to the application. So if you are using a commercial packaged app, there's no need to change anything. There's no SQL changes required. You just need to enable compression for the data. There's no changes to the application whatsoever. Any size OLTP or data warehouse can use advanced compression. Used to be in the past, we would say only the largest databases should be using compression, but we've actually changed that in the last couple of years. We now recommend that any size OLTP or data warehouse application should use compression. And the reason is that even for the smallest tables and partitions and databases, you'll still see storage savings and performance benefits by using app compression. So essentially, any size application, whether it's OLTP or data warehouse, can use and they're recommended to use compression. What are some of the key features of advanced compression? Advanced compression is comprised of a large number of capabilities that are included as part of advanced compression. I picked out sort of the top four here, those being the ones that are most commonly used by our customers. And this includes advanced row compression, which is the data compression component of advanced compression, and is designed for both OLTP and data warehouse applications. It typically sees about a 50% reduction in storage footprint. Advanced index compression, as you might guess, is for index compression. Again, it's optimized for both data warehouse and OLTP applications, and typically also sees about a 50% reduction in storage footprint. RMAN backup compression, which is designed to not only compress the backup itself, so as you do the backup, you can determine how much compression you want to apply, whether low, medium, or high. But an additional benefit is that data that is compressed already, meaning that it's been compressed either by advanced row compression or advanced index compression, remains compressed during the backup and recovery. And there's advanced lob compression. If you're using secure files to store your lobs out of line, then you can use advanced lob compression to compress those lobs. Typically, about a 50% reduction in storage footprint is also very typical with advanced lob compression. Some compression features that are included with Enterprise Edition include hybrid Columnar compression, or what we call HCC. This is both the warehouse level and the archive level compression for HCC. Now, HCC is included with Enterprise Edition, but you must be using one of the platforms above the screen in order to use hybrid Columnar compression. This includes Exadata, Supercluster, Cooler Axiom, CFSSA, Storage, FS1, Oracle Database Appliance. If you're using one of those platforms and you are on Enterprise Edition, you can use hybrid Columnar compression as part of the Enterprise Edition license. Nice thing about that is designed for data warehouse applications. It gets typically about somewhere between a 6x to 15x level of compression ratio. So it does a very high compression ratio. But again, it's designed for applications which are read-only, read mostly, with very limited or no DML operations. Also included with Enterprise Edition is called prefix key compression, which is index compression. Gets about a 50% storage reduction and is designed for both OLTP and data warehouse applications. And there's basic table compression, which is the free data compression included with Enterprise Edition. It gets about a 50% reduction in storage footprint, but it is designed primarily for data warehouses. You typically would not want to use that with OLTP applications because the data is only compressed when it's loaded. The data compression is not maintained during DML operations. But it is good to note that these are included with Enterprise Edition. So if you just want some basic index compression, data compression, or if you're on one of the platforms that supports hybrid Columnar, these are available to you if you're running Enterprise Edition. The typical compression benefits. The three primary benefits that we hear most from our customers. And the first one is deferring or eliminating future storage purchases. When you think about it, advanced compression, typically, whether it's indexes, data, or lobs, typically reduces the storage footprint by about 50% for those objects. Now, this is not only the existing storage, so you're better utilizing your existing storage, but this is also future storage as well. So if you reduce your current storage and your incoming future storage by 50%, then that will help you to either defer or eliminate future storage purchases or leases, maybe by 1, 2, 3, or more years. So instead of buying storage every year, think about if you could defer or eliminate those purchases and maybe buy storage every 2 or 3 years, or reduce the amount of storage you're leasing. This is one of the biggest benefits our customers see from using our database compression. Also, it helps improve query performance. We keep our data indexes compressed in memory, which means we can do a lot of operations against the data indexes in memory without having to uncompress. This typically is not possible with storage-based compression. This means a lot less IOs going on. This means typically a lot less, you better utilize the existing data buffers. So it is very typical that our customers report query performance improvements when using the database compression. And as I sort of mentioned before, better, faster RMAN backup recovery. Because what's already compressed stays compressed during a backup recovery, that means we're backing up and restoring a much smaller footprint. In some cases, our customers report they're reducing their backup recovery times by 33% or more. Enabling data compression. There's 3 different ways to enable database compression for existing data while that data is still being online and available. The first is a pretty common and pretty well-known capability within Oracle, online redefinition, that allows you to keep your tables online for both read and write activity while those tables are being enabled for compression. So typically when you enable compression for an existing table, you're compressing the entire table at one time. And it's also true of alter table move with the online keyword. So you do an alter table move online. This again allows you to compress the entire table while it's still being accessed, and it allows you to compress the entire segment at one time. So again, both these are designed to compress existing tables and to enable compression for the existing tables while still allowing access to those tables. Just as a side note, online redefinition is pretty commonly used by a lot of our customers when they're enabling compression for an existing table. One other way to enable compression on existing tables is using what we call automatic data optimization, or ADO. Now, ADO is a feature of advanced compression, and I'll point you to some more information about this at the end of the session here. ADO allows you to do what's very similar to online redef and alter table move by enabling you to enable compression for an existing table for the entire segment. So again, you could use ADO to compress an entire segment of an existing table and to enable compression for that table. But one difference also, it also has the capability to enable compression at the row level. So as I mentioned, all 3 of these will compress the entire segment. ADO also has the ability to compress at the row level, which means that instead of having to rebuild the entire segment, you can compress individual blocks. So this allows you to rebuild the table, essentially to enable compression for the table without having to rebuild that table. So you can do it in place. So all 3 of these methods will allow you to enable compression for an existing table by rebuilding that table. But also ADO will allow you to enable compression at the row level, which allows you to enable compression block by block without having to rebuild that table or move it. So these are the 3 most common methods for enabling compression from an existing table. And I have to say probably online redefinition is probably the most frequently used of all these 3 that when I talk to customers, they indicate that online redef is probably the most common. Some best practice insights around compression. So the first 2 here look at a very common question. And the question is, should I compress everything or just compress my largest tables only? So the argument for compressing everything is that it enables you to get all the benefits for all your tables, regardless of the size. So as I mentioned earlier, it used to be in the past, we'd only recommend compressing just the largest ones, and we would overlook or not suggest compressing the smaller ones for no other reason than we just thought that you get the biggest sort of bang for the buck of compressing the largest tables. And what our customers came to tell us was that even the smallest tables will compress by 50% or more typically. So it may not be the huge amount of savings for a small table, but there still is savings there in terms of storage reduction. So even with your smallest tables, you'll still see some storage reduction typically. But the biggest benefit is that you'll still gain the performance benefits of compressing even the smallest tables. Reduced I/O, the data indexes will stay compressed in memory. So typically, you'll see better query performance for even your smallest tables, and some of those small tables may become memory resident. So compressing everything is definitely a possibility, and you'll get all the benefits by doing that. You'll get the better performance. The data indexes will stay compressed in memory for all the tables that are compressed. You'll get a smaller footprint for even the smallest tables. So there are benefits to get compress everything. Now, some customers will draw a line sort of arbitrarily and say anything that's smaller than this, below this line, any table that's below this line, I'm not going to compress, and that's fine too. So you can compress only the largest tables and just choose at what point you draw that line and say anything smaller than this won't be compressed. And that's another way to approach this as well. It's also a common way customers look at this. So it is a very common way to approach sort of the discussion about compress everything or just large tables. Some of the cons about doing this, you're not getting the full storage benefits that since not all the data indexes are being compressed. You're not getting all the benefits of reducing the I/O because some tables will still be in their full uncompressed size, and you won't get full benefits of data indexes staying compressed memory because not all the tables will be compressed. So there are the pros are that if you have a large number of tables, you're not taking the time to compress all those tables. You're just compressing the ones that are possibly the most commonly used or just the largest tables. So there are pros and cons to each methodology. You can pick and choose either the number of tables you want to compress or you can compress everything. Um, if you look at our customers, they're pretty evenly split among whether they're compressing everything or just largest tables. So you leave it to your organization to decide how you want to approach this. There are pros and cons to each. Hopefully, this slide will help you sort of make some decisions around that. There are three levels of compression. There's table, partition, and table space. Table level compression means you're compressing the entire table. Partition means you're compressing the entire partition, or you can compress the table space level, but you can set a default in the table space, which says that any table or index that's built there will automatically be compressed, or if you rebuild it, that table or index will be automatically compressed. So you can compress the table level, the partition level, or the table space level. You can have, going back to the data compression, you can have some partitions that are advanced row compressed. You can have some partitions that are hybrid Columnar compressed within the same table if you like as well. Some additional insights. Update compression. When we actually perform compression on an update, when you perform an update, doing DML update, we actually don't compress that time when we do the update. We'll come back later, and when that block fills up again, we'll go ahead and sort of recompress that block. If we need more space for the update, we're going to look at percent free, and we're going to pull that space out percent free when we go back and do the update. What you want to avoid is running out of free space. You want to make sure your percent free is set adequately for the amount of updates you expect to occur to your blocks. If you expect a lot of updates, you probably want to make sure your percent free is adjusted a little higher than the default, which is 10. So this is just an insight to sort of set the thought and process that if take a look, if you expect to be doing a lot of updates, you want to make sure your percent free is having enough space reserved for those updates. You don't want to run out of space because then you might see some row movement, you might see some row chaining going on, which would impact performance. Now, this is true whether the data is compressed or not, but just want to bring it to your attention here is that if you do expect a lot of updates, make sure your percent free is probably adjusted higher than the default to make sure you have enough space to do those updates and not having row chaining going on. If there is row chaining going on, if it does occur, if you didn't have enough percent free available and you had to do some row chaining in Oracle Database 12CR2, we did implement the capability to compress the rows that are chained as well. So prior to 12CR2, we did not compress the chain rows. In 12CR2 and above, we do compress the chain rows if it does occur. And in-place row-level compression. As I mentioned earlier, ADO, and I won't go back through this again, but just to reiterate again, if you don't want to move, when you enable compression, if you don't want the table to be rebuilt and moved, because it's going to, if you do an online redefinition, alter table move, it's going to rebuild the table, then drop the old one. If you don't want to have that occur and you want the compression to occur in place without having to rebuild the table, you can use automatic deoptimization at the row level, which will rebuild it block by block, but it will not require the rebuild the entire segment, and it will not require that the entire segment be moved. So you can rebuild and to enable compression for an existing table by using the row level ADO capability, which means you don't have to rebuild that table in its entirety. You can actually just compress block by block. Some more compression insights. Array insert compression. Before database 12c, release 2, array inserts such as insert as select cause multiple recompressions per block. We now have better optimized that. So the number of rows that would be compressed in a block is computed earlier on, and it's a much more efficient operation. I bring this up other than just to let you know that 12c in Oracle Database 12c Release 2, this is much more efficient operation than it was in early releases. This is nothing you have to do internally. The database will figure this out itself and do this optimization for you. And just we are looking at ways to improve performance, and this is one of the ways we did it. Also, additional insights is that our compression works very well with the transparent data encryption from Oracle. The thing to keep in mind is that the best way to implement advanced compression and TDE together is to do the table space level, because the compression is done before the encryption, which means you get the maximum benefit of the compression before the encryption. If you use column level encryption, then the compression is done after the encryption, which means there could be impact on the compression ratios because it would have been done after the encryption was done. So if you're using TDE, transparent data encryption, along with our compression, then our recommendation is to use table space level encryption if you're using compression as well. But they work very well together. They do complement each other quite a bit. One of the largest, or one of the most common questions we get is it possible to improve compression ratios? There are some possible ways to improve your compression ratios. You can sort the data. Now, one of the ways we get compression is we're doing essentially a deduping of the blocks. So the greater amount of duplicate values that exist in the block, the greater the amount of compression you're typically going to see. So again, the greater amount of duplication exists, the greater the amount of higher the compression ratio. So the more you can do to get similar value duplicate data closer together on the block, typically the better your compression ratio. And one way customers will do this is they'll sort the data prior to loading the data, with the hopes that by storing the data, they'll get much greater number of duplicate values together on the same block. I've seen some customers do this and actually get some decent return out of this effort. One thing I will suggest is that you want to test this. You want to make sure that the amount of effort it takes to do this doesn't outweigh the benefits in terms of the compression, meaning that if your compression ratio before sorting, say, for instance, was 2.x, you get 2.x compression ratio, and you sort the data and you got your compression ratio was 2.1, well, the effort it took probably isn't great enough, or the effort it took isn't producing a great enough effort to make it worth or great enough pressure ratio to make the effort worth the while. But if you went from a 2.0 compression ratio to let's say 3.0 compression ratio, then it might be worth the extra effort it took to sort the data in terms of the compression ratio. You want to test this to make sure you are seeing a significant increase in the compression ratio to warrant the extra work it takes to sort the data. Some customers will think about larger block sizes. Again, the larger the block size, the more duplicate values that can exist. Again, I've not heard of many people doing this, and I would heavily suggest testing this before any such effort was done. But it is, in theory, a possibility that you could get more duplicate values in the block if you increase the size of the block. Can you change the method of bulk loads? If you change the method of how you load your data, will that impact the compression ratio? And it should typically no. Changing the way data is loaded, whether you're using online redefinition or alter table move, won't change the compression ratio. Again, the compression ratio, especially for advanced compression, row compressions, is primarily around data deduplication, reducing the amount of duplicates in the block. So the greater amount of duplicates you have, the greater the compression ratio. Hybrid Columnar compression, that's one of the ways, but there's also a lot of different ways hybrid Columnar will do its compression. So how you actually load the data doesn't really impact the compression ratio, short of maybe, like I said earlier, if you're sorting the data, that might have impact. But the methodology, whether you choose to online redef or an alter table move, won't change the compression ratio. Some other things to keep in mind, as I mentioned earlier, road chaining. Again, running out percent free could lead to road chaining. Just want to make sure your percent free is set for an adequate amount to deal with any updates that are going to occur. You want to make sure you have some free space available if you're going to updates are going to require more space, so you don't run out of space and cause road chaining on. If you're doing bulk loads, the recommendation is typically use a direct path bulk load. Direct path is optimized for compression. It provides better load performance. You can do things like the insert appendant. You can use create table selects, SQL loader, et cetera, et cetera. Anything that is direct path typically will see a better performance in terms of its load times because it's a very straightforward operation. We buffer it up, we compress it, we write once above the high water mark. It's much more straightforward than going through a conventional path, which would require possibly multiple recompressions of the same block over and over again, depending on how the data is loaded. So a direct path, you write the block once, it's already compressed. If you do a conventional path, it may require multiple recompressions of the same block as that block fills back up multiple times. So the recommendation again is if you're doing a bulk load, to use direct path bulk loads. Customers also ask what's the typical overhead associated with advanced compression. It's about 3 to 5% CPU is the typical overhead associated with advanced compression. But again, your testing would really show what the actual numbers for your data, your applications is. Part of that overhead is offset by the reduction IO and reduction of IO related operations. So 3 to 5% CPU is very typical. Some of that will be offset by reduced IO. But again, you would want to test in your own environment to make sure. Some more things to keep in mind. There's something called prefix index key compression bloat. Now, as I mentioned, there's a free version of index compression that's included with Enterprise Edition. It's called prefix key compression. It is possible with the free version that the amount of overhead it takes to compress or to manage the compression will outweigh the amount of compression you will get with the free version of the index key compression. It turns out that when you use the prefix key compression, that there is a certain amount of overhead to manage sort of the compression, and that overhead has to be less than the amount of compression you're getting. Because if it's taking more overhead to manage the compression than the compression you're getting, then you can actually see the index start to grow in size. Now, this is fairly uncommon. I think in the last few years, I've only seen this occur a few times. But I just want to make you aware of the fact that the free prefix index key compression can see the index grow in size when it's not expected to grow in size. And again, it's due to the overhead of the managing the compression outweighs the amount of compression you're seeing. I've only seen this occur a very rare amount of times, maybe once or twice in the last couple of years. So it's very uncommon, but I just want to make you aware of something to keep watch for. If somebody would ever say you turn on this index compression and the index is getting larger for some reason. As I mentioned earlier, there's an index compression capability included with advanced compression. It's called advanced index compression. Advanced index compression won't allow this to occur because it would have figured out ahead of time that this is a possibility. It would not allow the index to be created because there won't be any benefit out of compressing the indexes. But I just want to make you aware that if you're using the prefix index key compression, the possibility of it growing in size is very rare, but it is possible. And just keep this back in mind if anybody would ever say that they've seen some growth in indexes, and this could be what's happening. And if that's the case, you would not want to use the index key compression with that key at that point because there's just not enough compressibility in that index to make it worthwhile. In 11GR1, Oracle Database 11GR1, it was possible that some updates would cause tables and partitions to grow in size. Again, this was repaired or should we say fixed in Oracle Database 11GR2 and backported to 11GR1. I only bring this up because if you're running Oracle Database 11GR1 and you have not patched it, it is possible that you could see any updates on a compressed table cause that table to grow in size. Our fixes for this were implemented in MGR2 and backported. So typically the only time you would ever see this is if you had unpatched MGR1 application or databases out there. Again, same type of thing is that you would see the table grow in size after updates. You want to make sure that if you're on MGR1, you have applied patches for advanced compression. If you're 11GR2 and above, you won't see this issue any longer because these issues are resolved in those releases and beyond. If you're using advanced lob compression to compress your lobs, it is possible that you won't see much compression from lobs if that lob has already been compressed. If whatever created that lob has already compressed that lob, it's unlikely you will see any additional compression with that lob. So if whatever created it, whatever third-party product created that lob has compressed it, that's very unlikely, or it's very possible that you won't see any additional compression out of it because it's already been compressed. Some best practice. This is a partial list. There's a full list in the advanced compression tech brief. Space reduction with advanced compression gives the best results when the most duplicate data is stored. So again, in order to get the best results with the database compression, specifically advanced row compression, you want to make sure you have duplicate data. The more unique the data, the lower the compression ratio. Although CPU overhead is typically minimal, implementing advanced row compression is ideal on systems with available CPU cycles, as compression will have additional although minor overhead on some DML operations. If you're short of CPU resources, compression is not going to help that. Compression will help if you're short of I/O resources. If you're I/O bound, compression can be very useful in that environment. If you're CPU bound, I would not expect much benefit there because, like I mentioned earlier, there is additional overhead in terms of CPU. It's not that much, but there is some additional CPU overhead. If you're already short of CPU resources, that could be an issue. Index organized tables are essentially indexes, and they cannot be compressed with advanced row or basic table compression. IoTs can be compressed with a free prefix compression. And Oracle Database compression works well with Oracle Database table level data encryption. Transparent data encryption, unlike storage-based compression that can have difficulties in compressing encrypted data. So again, our compression works very well with Oracle TDE, and in some cases, it may be a better choice than using storage-based compression because often those third-party storage-based compression has difficulties compressing encrypted data. Our compression works very well with our transparent data encryption. It is recommended that lobs over 4K in size be managed using secure files. The advanced lob compression deduplication features of advanced compression reduce the amount of storage required for secure file lobs. Again, this is just a partial list. There's a full list in the tech brief. I'll point you to that at the end of the session. Get us started with compression. We usually recommend a proof of concept if possible. And the reason we do this is that testing ensures that organizations will really know how their application will perform with compression and how much storage reduction to expect. And it avoids any surprises or concerns when moving compression to production. It's pretty rare that compression proof of concept doesn't go well or show benefits related to storage savings and improved performance. So it is, again, recommended to perform a proof of concept for our compression capabilities. Some considerations around that proof of concept is test with your actual data and applications. Don't create special test data or special test applications to test compression. You really want to test your own data to see how well your data will compress because your data is going to compress different than other data. And you also want to test your own applications because you want to see how your applications perform in that environment. Many times we've seen people create special data or special applications that show how compression works with that special data and those special applications. But what you really want to know is how it works with your data and your applications. Test the features that are most common that you expect would be the ones you're going to use. If you use some data compression, then test with advanced row compression or hybrid Columnar compression. Index compression, you want to test with advanced index compression or the free version of our index compression, and etc. So test the features that you really think you're going to use. Test a range of application operations. If you're doing do inserts and queries and direct or bulk loads, RMAP backups, test all those. Make sure you run your queries, run your bulk loads, run your DML inserts and updates and things like that. See how they perform. See how they perform before compression, see how they perform after compression. This kind of ties into the last point here is track performance and verify storage reduction. You'll see once you start compressing, you'll see how much reduction you get. Also, you want to see how the performance is either benefits or impacted by compression. And one of the great ways doing that is using what's called Oracle Real Application Testing can be useful for that. But most typically, what our customers do is they run their application before compression, they run their application after compression, and they compare the results of both. So you want to learn, you want to see how compression is going to be in your environment, with your data, and your applications. One of the ways to sort of get an idea of how much storage savings you can expect is to run our free compression advisor. It's included with Enterprise Edition. It's called DBMS_compression. You can search in the documentation for DBMS_compression. It allows you, you can sort of see an example of under advisor usage example of running it, and you can choose to run it for your data, either hybrid Columnar or advanced row compression for your indexes and lobs. It'll come back and estimate the compression ratio. So in the bottom there, you can see the compression ratio is 2.65, was about a 50% reduction in the storage footprint. It is fairly accurate. Actually, it's very accurate, what we've been finding. And so it will give you a very good estimation of what your compression ratio will be. It actually samples the data and then compresses that data. And it gives you, as I said, a fairly good estimation of the compression ratios you're going to see. It does not require advanced compression option license to use, just requires DBE. And you can actually estimate your hybrid Columnar compression on any platform. It does not have to be an Exadata platform to estimate your hybrid Columnar compression storage savings. So again, this works with data indexes and lobs. It can run on essentially any platform that runs Enterprise Edition. It'll give you a very good estimation of your compression ratios. On the far right is the white paper on getting started with Oracle Compression Advisor. It'll give you a good idea of how to use it. And you can also search in documentation for DBMS_compression. That does not require an advanced compression option license to use. It just requires Oracle Database Enterprise Edition. If you're thinking about a proof of concept for compression capabilities, I highly suggest taking a look at this document, the Oracle Advanced Compression Proof of Concept Guidelines, Insights, and Best Practices. It goes through the best practices. It talks a lot about in more depth about some of the things we talked about today, and it does give a sample outline for a proof of concept. It doesn't do sort of a walkthrough of how to do it step by step, but it does give you ideas about what to look for, what to test for, some things to think about, that type of thing. And again, this is available on oracle.com, and I'll point you to how to get that at the end of the session. So for more information about some of the things we talked about today, I highly suggest these three areas. First is the first one listed there is the actual oracle.com webpage for advanced compression. It's on the top right there. You can go to that webpage, use the link directly to its left, and it will provide all the white papers about advanced compression and hybrid Columnar compression and ADO. So if you look for white papers on implementing information lifecycle management, those papers will talk about ADO on the Oracle Advanced Compression webpage on oracle.com. There's white papers there that talk about all the features of advanced compression. There's white papers there that talk about hybrid Columnar compression. There's white papers there that talk about performing POCs, about using Compression Advisor, and there's customer testimonials about their usage of advanced compression. So I highly recommend taking a look at that page. Second one listed there is the blog for advanced compression and for database compression in general. Then the third one is my Twitter site, my Twitter handle, ACO_Greg. So feel free to reach out to me through that if you have any questions. I want to thank you for joining me today. Hopefully you found this useful. Again, I highly suggest reaching out to any of this information if you want more information about using advanced compression, hybrid Columnar compression, or any of the database compression capabilities of Oracle. Thank you for your attention. Again, thank you for joining me.